So without further ado, I think we could go ahead and think about getting started for the day. And I'll do our first introduction, which is I'm very pleased to be able to introduce Dr. Daniele Prati, who is already had his entire workday completed because he's in Milan. And so is at the main university hospital in Milano, which is, my Italian is terrible, so I apologize, Daniele, I'm going to butcher the name of your institution, but it's Grande Ospedale Maggiore Policlinico, and this is the main university hospital in Milan. Dr. Prati received his medical degree in Milan and also completed his residency in hematology. His scientific interests are focused in the epidemiology, diagnosis, and treatment of transfusion-transmitted infections and chronic liver disease, as well as on different aspects of blood transfusion, safety, and efficacy. He's published numerous scientific papers on these topics and served on several committees, advisory boards, and governing boards of national and international scientific associations. So I'm very pleased that he was willing to join us today. So Daniele, I think you can go ahead and share your screen, put your slides up and share your screen.
So
should be the little green box in the bottom. Yep.
Are you?
Yep, it's coming.
Okay.
Yeah.
Very good. So first of all, thank you, Dana, and I wish to thank all the other organizers for this invitation to the Norman Bethune Symposium. As you may know, I am not really an expert on blood group genetics, and I have to say that like most clinical blood transfusion physicians, I always thought that the ABO was there only to hassle technicians and causing transfusion reactions. And the reason why I'm here today is probably because Northern Italy has been hit very early and hard during the first wave of the COVID-19 pandemic. And we had just the opportunity to make observations before the rest of the world. And in this regard, during this presentation, I will try to outline a little background on the associations of the abiogenetics with infection susceptibility. I will briefly show about the phenotypic and genetic association studies in COVID-19, both the initial data and the population studies on genetics. I will mention something on anti-red cell reactivity, other aspects of anti-red cell reactivity in COVID-19, and move to conclusions. So this was actually the very first evidence of ABO and COVID-19 association. Has been published in China very early, you see, March 27. The researchers have shown that the blood group A was associated with a higher risk of acquiring the COVID-19 compared to non-A blood groups, whereas the blood group O was associated with a lower risk for the infection. And I have to say that our first reaction
Daniele, we actually aren't seeing your full slides yet. We're getting a message that says you've started screen sharing, but the deck's not coming through. So maybe we try to load it up again.
So you're not seeing the slides?
No, not yet. I mean, I do have your slides, so I can show them if you'd like.
Maybe it's better. I don't know. Maybe that from here. Let's see if it's better. Now, are you?
Yeah, no, we're only getting a message that says you've started to share your screen, but we're not actually seeing the slides.
Oh, that's
so that's okay. Why don't I'll drive your slides. That'll
okay.
work.
Okay.
That's why we asked everyone for them. So just bear with me for 1 second while I get that set up. Okay. So
okay.
Can you see the slides now?
Yes, yes, I'm seeing. Next one.
Okay.
Okay. Okay. This was the outline I already mentioned. So the next one. So this is, as I said, that was the first evidence of an association between IBO and COVID-19 that was shown by this Chinese group very early during the pandemic. And this, okay, no, this is moving. Are you see, which slides are you seeing?
We're seeing the paper, the Chinese paper.
Okay, you have not seen the next slide?
Not yet. You want me to move it?
So yeah, just move it to the next one. Okay, this was our first reaction to the Chinese paper. So we were quite skeptical to this data, just because, may I have the next slide, please? Because, you know, in almost 1 century, very weird blood group associations have been described, and most were due to uncontrolled statistics, mainly because the ethnicity was not controlled. Some of these associations are quite funny. For example, this one from Warnowski said that hangover is worse in individuals of group A, while group B have defecated the most. Group O have better dentition. There was the Japanese theory on blood type and personality spanning from the 30s to the 70s. But there were also some important papers on very high impact scientific journals, hypothesizing relations between the blood group and IQ, or the blood group and socioeconomic status. There was also the very well-known link between the IBO and diet that actually we know is not based on valid data. However, I have to think, the next slide, that some truth about IBO and disease does exist. We know, as has been reviewed in a nice paper by SBT, in which also Dana has been involved. IBO is not just red cell antigen. We know that other blood cell may absorb ABH expressing sphingolipids from plasma, where they do circulate attached to plasma lipoproteins. So it's more an histoblood group antigen than only a red cell antigen. The A and B glycosyltransferases can modify the glycans on the von Willebrand factor. And it's known that group O individuals have a shorter life of von Willebrand factors, and has also a reduced activity of von Willebrand and factor VIII levels, which leads to a lower risk of thrombosis, inflammations, and probably also some type of cancers. The next slide, please. And there is also a relation between ABO type and infections. We know that the ABO type has been associated with several infectious diseases, including bacterial, but also viral infections, including norovirus, retrovirus, chikungunya, and even the SARS-CoV-1. And the possible mechanisms of these relations are linked to the APH antigens that may act as a receptor for pathogens due to the presence of natural anti-B and anti-A isoglutinins that may act as inhibitors of infection. And there is also a possibility of the molecular mimicry driven by blood group antigens between the pathogen and the host. The next one. So we gradually became less skeptical on the role of ABO in COVID-19, and these were the two main reasons. First, the first was the clinical observations. We noticed that during the peak of the epidemic, when our hospital was 95% dedicated to the care of the COVID-19 patients, we noticed that there was an increased request for non-O red cell units, and this led actually to a temporary inventory shortage. And next, we also had access to the experimental data. We had the opportunity to see the very preliminary data generated by the COVID-19 GWAS group, in which we participated as active, participants, giving genetic samples from more than 1,500 patients and blood donors that were collected at our hospital and stored at our biobank during the first wave of the pandemic. And in this study, a role of ABO was indicated. Next slide shows why. This is the outline of the study. As you see, as you can see, there was these are only the patients that were studied by our group, and most of the others were given by Spanish groups. And the study spanned between late February, when the first samples were collected, until May, when the first results came out. Next one. And these shows the main results. We identified a chromosome 3 gene cluster as a genetic susceptibility locus, on the left side of the panel. But also we confirmed the potential involvement of the ABO blood group system, because on the right side of the panel, you see the RS57152 means the ABO blood group. So this confirming, actually, may I have the next one? Confirming an odds ratio of 1.5 for A versus non-A. Thank you. The next one. Next, some other data were published. These were quite impressive for the number indeed that have been studied. Were provided by Denmark, by a Danish study. And as you see here, again, the group O was less represented among positive patients with SARS-CoV-2 with respect to others, to the control population. The next one. This paper has been published in Nature Genetics and report the data from the 23andMe program that you probably know better, even better than me. It's a commercial agency making determinations of the genetic profile of volunteer individuals. They pay for this analysis. They had the opportunity to analyze their database in relation to the presence or absence of COVID-19. And they found, as you can see on the upper panel, a role for ABO when the comparison was made between test positive versus test negative, while there was no relations of the ABO when severe respiratory symptoms were considered in the lower panel. And these data actually supported the role for ABO in susceptibility to infection rather than severity of the disease, and suggest that the blood type O is protective. The next one. These data have been published very recently in Nature, and here again, the suggestion from this meta-analysis of different groups suggests that ABO is associated with susceptibility to infections, but not to critical illness. And the next one. But probably the definitive proof of an association is given by this large database that actually aggregated the data from 48 groups around the world that provided the last view of both severity and susceptibility with 14,000 hospitalized cases and near 50,000 PCR positive cases overall included. And you can see from the upper panel, may I click just one? Okay, you can see here is the chromosome 3 cluster on the upper panel, and the ABO is on the lower panel. And next one, please. So once again, suggesting a role in, sorry, may I have the previous one, because I didn't show you that these was the reported infection cases on the lower panel, while on the upper panel is the hospitalized. So the ABO is not determinant in hospitalization, while the chromosome 3 is more determinant in hospitalization. The next one. So we also shown that ABO has a role in mild and asymptomatic infection. These are the data still in preparation at our center of a study. We included donors from the Milano blood donor cohort. We started in July 2020, sorry, to analyze patients and samples. We enrolled almost 9,000 blood donors right now, and for almost 2,000 baseline negative donors, we had the opportunity to repeat the samples for collecting the incidence data calculation. We found a 10% seroconversion, but next one. As you can see here, even in seroconversion, blood group non-O was one of the main determinants of seroconversion. So it's a proof that non-O blood donors have a higher likelihood of seroconverting to antibodies, so to acquiring the infection. Next one. And this is a possible explanation for this finding. Since the virus is produced by AB and AB individuals are decorated by AB and AB blood group epitopes, types O individuals are more protected because of the presence of anti-A and anti-B in their serum. The next one. We also studied the secretor status or non-secretor status phenotypes in our cases from the cohort that has been published in the New England Journal. As you can see here, we studied the main determinant of non-secretor phenotype, which is the G to A variant. As you can see in the middle bars here, the in-hospital mortality was reduced in patients bearing a non-secretor phenotype, mainly due to effect of group A patients. So in group A patients, this was associated with a lower in-hospital mortality. The next one. And the possible interpretation of the protected role of non-secretor status is that if we think that the mechanism for entry into host cells of viruses decorated by host glycans, as we can see, so bearing the A and B antigens, is that ABH glycans on SARS-CoV-2 protein may enhance the binding to target cell receptors, for example, the ACE2 receptor. And the ABH glycans on target cells may also serve as alternative receptors for SARS-CoV-2, which may enhance infection. And both these mechanisms are inhibited in non-secretors and no blood group or individuals. Next one. This slide has been published by the ISBT COVID-19 working group, and I think is very illustrative and again summarizes the role of antibodies, the mechanism 1 and 2, the possible role of glycans decorated on the surface of the viruses of host that have host origin that may either enhance the binding or serve as alternative receptors, and also consider the possibility of other mechanisms related to this that we have mentioned, include that in group A, individuals AC1 activity may predispose to cardiovascular complications, so giving a more severe disease, and also the possible role in increasing the von Willebrand factor and factor VIII levels in group A patients. Next one. But there's also a role of IBO and red cells or different mechanism due to, for example, to autoimmunity. Next slide. This is a paper that we have published quite early during the epidemic, because we have noticed that hospitalized patients with COVID-19 had a high prevalence of DAT positivity, direct antiglobulin test positivity, due to antibodies linked to the red cell membranes, up to 46% during the first wave of the pandemic. The mechanism was infection related. It was very well summarized in the editorial by Dr. Hendrickson. Below, as you can see, the red cells, the antibodies bound to red cells and eluted to red cells did react actually with other red cells coming from COVID-19 patients, but not with standard reagent red cells, demonstrating that probably the link between the antibodies and the red cells was disease specific. We also shown that these conditions were associated with an increasing frequency of anemia and greater transfusion requirements. And we also make the hypothesis that this phenomenon could be ABO involved, but I have to say that investigating these associations was not possible in this series because we were very early and we did not have enough data. Next one. But some idea that also the autoimmunity may have a role in this association came from these other papers published by Luca Valenti of my group that have shown that the complement some fraction complement levels, C5a, C5b9 levels were higher in non-O blood group patients when there was the main determinant of severity, so the GA mutation on the chromosome cluster site on. So as you can see here, again, probably this suggests that ABO and chromosome 3 may interact in promoting complement activation and so promoting autoimmunity. Next one. So the key message I would like to give you today is that in our opinion, the no O blood group, so the mainly A, is associated with an increased risk of COVID-19 in multiple ethnic groups, so independently from that group. The association is mainly driven by an increased risk of infection rather than an increase of disease severity. The natural anti-A antibodies may inhibit the spike AC2 interaction by interfering with carbohydrate and carbohydratic interactions. And a non-secretor genotype, especially in A subjects, may be protective for severe infection. the role of autoimmune mechanism involving complement activation and interaction of ABO with chromosome 3 cluster needed to be further explored. And however, I would like to remark that these COVID-19 and ABO relations have no direct clinical implications, at least at the moment, but may help to explain the mechanism of the pathophysiology of COVID-19 in our opinion. There are several other open aspects, including it is not known, for example, if the level of isoagglutinin may play a role, as this has not been very well demonstrated so far. And also another important point probably to clarify is if this different susceptibility to infection also reflects differences in response to vaccines. And we would like also to know if this association between ABO and COVID-19 is maintained also with newly emerged variants, because this could be probably a way of escaping from the immune system of the host and giving the virus more aggressive, as we have known with these variants. So the next one. These are, I would like to thank all the people of my group, and particularly Luca Valenti, who has done most of the, has coordinated most of the study, and also the international collaborations. The next one. I would like to finish with this slide. This year in Italy, we are celebrating the 7th century from Dante Alighieri's death, and I would like to finish with the very last verse of his Inferno that are pronounced by the poet when Dante and Virgil, that accompanies him, get out from hell and arrive to the Purgatory beach. The sentence is quindi uscimmo a rivedere le stelle, which in English has been translated, and thence we came forth to see again the stars. And I think it's a good omen for the end of this epidemic and an invitation to come to Italy soon. In this regard, the next one. I would remind that I stay here at the Maringoni Pavilion, here on the left side, which is our hospital is actually in the center of Milan, and in a walking distance you can reach Piazza Duomo, Velasca Tower, and also the old university building. And so please, if you come to Milano, come in and say hello. Thank you very much.
Thank you very much, Daniele. That was really interesting. We're happy to take questions. I will stop sharing this so that we get the full view back again. And you can either ask questions in the chat box, or you can put your hand up. Your choice.
Okay. Let's see the chat box. Okay, I can see, so from the chat box, I can see the chat box, but I can see any question from at the moment.
Can't hear you, Dana.
Yes, I can hear you.
Oh.
Oh. So,
sorry, I'm on mute.
I think that this question is very, very important, as if there has been any difference in susceptibility with the new variants of COVID. I cannot answer to this question, although we did a comparison of the relative prevalences in the patients hospitalized right now and 1 year ago. And actually, I have to say that the prevalence of A patients was a little bit lower right now. This might suggest some role of different variants, but really it's hard to say, and probably would need more sophisticated approaches than just going to see prevalence.
Okay. We have some hands up. WG.
Oh, hi there. Yes, Bill Gibson from UBC. Is there evidence of true molecular interactions and binding between the ABO blood group and the virus, or is that just a theoretical model at this time? Has that been demonstrated?
As far as I know, there is not really convincing at the moment. It's something that has been hypothesized, but also with SARS-CoV-1 that had a similar, and has been, I think, also deduced by the protein reconstruction, and so some mimicry of that.
Thank you.
Thank you.
Dr. Nee.
Yes, so Danielle, that was very impressive and important presentation. So my question actually is following the question is, in this different ABO type of the patients, so you clearly mentioned that symptoms that affect the infection, and both SE2 as well particular spike protein, including the RBD size, they heavily glycosylated. So I do not know whether this APO is any person use some of techniques such as mass spectrometry to study this glycosylation in the virus side be affected, or SE side this interaction be enhanced. So I would think this problem is very interesting. A question deserved to be answered.
I absolutely agree with you. Unfortunately, we are not able to do this kind of technically. We are to do this kind of studies, which are very sophisticated. But we have several samples, so we are very open to any collaboration. So if you think that something can be done, even from patients that, for example, experienced these strange forms of similar autoimmune hemolytic anemias.
Thank you.
Thank you.
Thanks. We have a question from Jill Johnson in the chat box asking, with all of the O versus non-O, do you think there's a role for B in addition to A?
Yes, there is also a role for B, which is probably less impressive. I don't know if this is just due to the numbers, and also this kind of these studies have been done in different ethnic groups, but usually some ethnic groups, those who had higher prevalence of B, were less represented. So I don't know if this may have a role, but I think that what comes really out is not the A, which is worse, but is the O that is better, in my opinion.
Dr. West.
Hello, yeah, it's Lori West in Edmonton. Thank you for that very interesting talk. Will you be looking more closely at the role of especially anti-A antibodies?
Yeah, I think that would be an idea. The idea was to make titration of anti-A antibodies, and we're looking for doing it, but this second wave was really dramatic here, so we have been really absorbed into routine, and we had much less time to make research. Hope that we will have to take out to raise the head again and restart to make something very soon. But again, we are very open to any cooperation if you have ideas.
Thank you.
Great. So I don't see any further questions in the chat box.
The variance, yes, the variance. I think I mentioned it. Yes, the variance. Yes, I've already answered probably. Yes, because of the different prevalences. Yes, okay.
Yeah. Okay, thank you very much, Daniele. That was just great.
Thank you very much.